Hi there, welcome back here. Let's say you were asked this question in your upcoming Jamb. Notice that Jamb is already 20 something days from here. All right, so let's say you came across this question, what would be your answer? It says a magnetic field is said to exist at a point if a force is dash. A force is exerted on a stationary charge at the point. Now, if a charge is stationary, now does a magnetic field act upon it? No. If you don't understand that concept, I'm going to link a video in the description where I explained all of these things. But of course, if you have seen this formula before, F is equal to BVQ, sine theta, if theta is less than 90 degree. So it shows here that this, Q, represent charge, right? Quantity of charge. Then V here is velocity vector. So it means that the charge has to have some speed. So if the charge has to have some speed, it therefore means that a stationary charge will not experience a magnetic force. Hence, there is no magnetic field acting on, at that point, or at that point where the charge is. Then it says that if the force is exerted on a moving charge, let's hold this for now. Maybe that makes sense. Option C says deflected at the point. That doesn't even make sense. A force is deflected at that point. It doesn't make sense. A force is strengthened at the point. A force, that doesn't make sense either. All right, let's look at this one that makes sense. It said exerted on a moving charge at that point. That makes sense. If the charge has velocity, it's therefore what? Moving. So if it has velocity, it's moving charge, so it means the force will act on it. So the answer is going to be B. All right. Then the next question says the SI unit. The SI unit, I wrote unit. The SI unit of magnetic flux density is what? The SI unit of magnetic flux density is what? Now, what confuses students is this. We have magnetic flux and magnetic flux density. Now, magnetic flux is denoted by phi. Magnetic flux density is B, vector B. Is that okay? And this one is scalar, this one is vector. This guy is scalar, this guy is vector. This guy is also called magnetic field intensity or magnetic field strength. So that is magnetic, so it's also called magnetic flux density rather, or magnetic field intensity or magnetic field strength, vector B. Why this one is just magnetic flux and it is a scalar. This guy is scalar, this guy is vector. Now this one is just represented by lines. This one is just the amount of lines of magnetic field lines. Is that okay? The amount of lines that the magnetic field has. Is that okay? That's magnetic flux. But magnetic flux density, the unit of this guy is Tesla, while the unit of this guy is Weber. Is that okay? So let's make sense of that. Farad is the unit of capacitor, so it cannot be our answer. Henry is the unit of inductance, so it cannot be our answer. Then Tesla or Weber are our two good options, but in fact we know already now that Weber is the unit of magnetic flux, not magnetic flux density. So the answer becomes Tesla. All right. If you did gain value, make sure to follow me and click the link in my bio to subscribe to my YouTube channel. I've explained everything on magnetism. God bless you as you do so.